everybody. Alright, in this chapter we are going to discover information about degree measures of the angles in a right triangle and also the ratios of the side lengths of these right triangles. So let's first start off with triangle ABC, right triangle ABC, and we are going to look at acute angle A in this triangle. We already know that the right angle, angle C, is 90 degrees, which means that angle A and angle B both have to be acute, or less than 90 degrees. So we're going to look at angle A since that's what the directions told us to do. Now, to compare ratios of side lengths in a right triangle, we're first going to look at what is called sine of angle A. You can abbreviate that with 3 letters, S-I-N, angle A, and that ratio is going to be the opposite side to angle A. So if you're here at angle A, what side is opposite? That's going to be side BC over then the hypotenuse. Well, the hypotenuse is always the side that's across from the right angle, so in this case angle C. And what side is that? Side BA. Okay, these side lengths could have numbers or unit measures associated with them. So let's say that side BC is 3 units long, side CA is 4 units long, and side AB, the hypotenuse, is 5 units long. So then this ratio, sine of angle A, is 3 over 5. Okay, next one. Another ratio is called cosine. Again, we're going to look at angle A. So cosine of angle A, that can be abbreviated again with 3 letters, COS, cosine of angle A. Now in this case, let me erase these arrows here. We're first going to look at the side that's adjacent to angle A. So adjacent, remember, is right next to it. So the side that's right next to it is side AC. And then the hypotenuse, again, is side BA. Then using the numbers, okay, well, side AC is 4 units long. The hypotenuse, side BA, is 5 units long. So the ratio is 4 over 5. Okay, last one. Tangent. This ratio can be abbreviated with 3 letters, TAN, tangent of A, equals opposite side over the adjacent side. So again, opposite to A, the side across from it is side BC. The side that's adjacent to angle A is AC, which then with numbers, that would be 3 over 4. Okay, good job. So now, we remember these ratios with this funny yet helpful word. Make sure to write this on your paper. We say this SOHCAHTOA. And the reason this helps us is that the S stands for sine, and sine is opposite over hypotenuse. C stands for cosine. Cosine is the adjacent side over the hypotenuse. And T stands for tangent, which is the opposite side over the adjacent side. You may also see it written this way, S and then opposite over hypotenuse, C adjacent over hypotenuse, and T for tangent, opposite over adjacent. Okay, let's try an example. So using right triangle ABC with acute angles A and B, we want to write each trig ratio in its simplified form. Okay, so first one, we have sine of angle A. We'll find angle A, which is here. So sine, remember, is opposite over hypotenuse. So opposite to A is 12. And the hypotenuse, remember that's across from the right angle, is 20. Well, hopefully you guys can see that 12 over 20 can be simplified further. You can divide both the numerator and the denominator by 4. So this will simplify to 3 over 5. And that would be our final answer. Okay, next one. Cosine of A. Okay, so cosine, remember, is adjacent, the adjacent side over the hypotenuse. So if we're still looking at A, adjacent to A would be side AC, which is 16 units long, over the hypotenuse, which is still 20. The hypotenuse doesn't change. Again, this can also be simplified by dividing the numerator and the denominator by 4, and you will get 4 over 5. Okay. Next one, tangent of A. Well, remember, tangent is opposite over adjacent. Okay, again, looking at A, opposite to A is the 12. Adjacent to A is the 16. And this can be simplified to 3 over 4. Okay, if you notice, there are 2 acute angles in this triangle, and so we don't have to necessarily look just at A. We could also focus our attention on angle B if we wanted to get information about the measure of this angle and the ratios of their sides. Okay, so looking at B, now we want to do sine as it compares to angle B. So here now, from angle B, opposite to B is side AC, which is 16. And then the hypotenuse, still across from the right angle, which is 20. So sine of B is 4 over 5. Okay. Cosine of B. Erase these arrows. Alright, so cosine, adjacent over hypotenuse. So adjacent to angle B would be side CB, or 12. And the hypotenuse still stays 20. So this simplifies then to 3 over 5. So cosine of B is 3/5. And then the last one, tangent. Tangent of B, okay, so that's opposite over adjacent. So opposite to B is 16. And adjacent to B would be the 12. And this simplifies to 4 over 3. Okay. Now let's look at one other example that's slightly different. Uses the same information though. I'm going to work backwards. Okay, so sine of what angle? Sine of blank equals 7 over 25. Well, if you can remember that the sine ratio, here let me write SOHCAHTOA over here for us. Sine ratio is the opposite side over the hypotenuse. Okay, well this 25 is the hypotenuse. Now the 7 is up here. What angle is the 7 opposite to? 7 is opposite to angle Y. So this would be sine of angle Y is 7 over 25. Okay. Next one. Tangent of what angle is 7 over 24? So remember, tangent is opposite over adjacent. So we want the 7 to be the opposite, and we want the 24 to be the adjacent. So what angle is 7 opposite to? 7 is opposite to y, and 24 is adjacent to angle y. So this one's also angle y. Okay, one more. Cosine of what angle equals 7 over 25? Well, cosine is adjacent over hypotenuse. So which side is adjacent? So if we have here that the 7 is adjacent, what angle is this side adjacent to? Be adjacent to angle x. And then the hypotenuse stays across from the right angle. So the answer here is angle x. Okay, good job guys. In class we'll talk about using our calculators to find some of these ratios as well.